Drones are the new tool for the wireless industry. Drones are fast, nimble, and gather high-resolution imagery that is second to none. Drones are ideal for cell site audits and surveys for new or proposed sites. How can we take advantage of drones in the wireless industry? It's three main areas: safety, accuracy, and cost. Let's talk a little bit about safety. Drones are remotely controlled from personnel on the ground. In a few seconds, a drone can fly to the top of a tower and gather data in minutes. A drone doesn't care about the complexity of a tower or how high a tower is, and excels at data collection in all cases, regardless of tough site access, structures that are unsafe, or sites with climbing restrictions. As a simple rule, the use of drones means less routine climbs, thus less exposure to risk. Where drones really excel is accuracy. Using the latest technology to turn 2D imagery into 3D models through photogrammetry, measurements can be made in post-processing with high accuracy, down to less than a 1/16 of an inch or better in most cases. This process eliminates human error in the field due to poorly taken measurements or incorrectly transcribed records taken often in harsh environments. Where the bottom line is watched closely, the cost of doing business is prime concern. Drones don't need man lifts, ropes, or safety gear to gather information. In most cases, deploying a drone to collect data will be cheaper than deploying a tower crew. However, the real value is in what the drone can capture that was previously unavailable through traditional methods. We'll learn more about this as we move through the project lifecycle in this video. One of the big cost savers is the drone's ability to capture a holistic picture of the site. Deploying a climbing team for one set objective is no longer valid. All data collected by the drone can be queried at any time in the future for a fraction of the cost of a tower crew redeployment. Once collected and processed, all data is available online through secure channels. There are 3 stages that need to happen after a work order is issued for site work using a drone. First, the flight, or data collection phase. Once the data is in hand, we move on to the processing phase, where the collected raw data is turned into a measurable data set. And finally, the third section, dealing with how the deliverables are created. Let's start with step 1, data collection. The collection of good data relies completely on the field process we have developed. The key is to capture data in a specific way to maximize the effectiveness of the data processing tools in the next step. This is critical, and as we'll state again later, it's the difference between an excellent and accurate model and a data set that will not process. Of course, not all sites are equal, and neither are the requirements for different types of deliverable, so the field processes and capture methods are required to be different also. Our techniques may be proprietary, but the basic premise is to use a drone to take high-resolution photographs of the structures requested. We use several models of high-end commercial equipment that carry specific payload suited to the task at hand. We ensure downtime is minimized by having backup equipment available in case of malfunction. We also mitigate risk by using equipment that is readily available on the commercial market, where the spares are plentiful. The second step in the drone audit activity is processing the collected data. All images collected contain geolocation data and heights from onboard barometric sensors. As the images are loaded, a visual representation is shown of the locations of the images and the images themselves in 3D space. To process data for the purpose of accurate measurements at a later stage, a point cloud must be created. A point cloud usually consists of millions of points in 3D space that each reference the original 2D images that make up that point. Once the point cloud is built, accurate measurements can be made simply in software and fine-tuned to pixel level. The data collection method is of course critical and is the bridge between accuracy in inches to 4 decimal places. or a completely unusable data set. As we zoom into the model, the point cloud becomes clearly visible. Here we can see an antenna height being measured, followed by the width of a TMA. "2D photographs can show the resulting measurement, overlays, and dimensions. Of course, this type of processing is not confined to merely linear measurements. As the drone provides a method of collecting points in three-dimensional space, measurements of surface areas and volumes can also be calculated. Here you can see the area of an existing compound being measured. This can help in lease negotiations with landlords and provide assistance in raw land new build applications. Using drones to map new or proposed locations can be an extremely effective tool in the site development arsenal. Drones can be used to visualize locational constraints and improve site selection due to the unique perspective gained. In this example, we've provided a high-resolution aerial orthomosaic with high zoom capability. The small yellow square circled by the cursor is the proposed location. Such an orthomosaic can be converted into several other views, for example, a digital surface model, where the different colors highlight the differences in altitude of the terrain. In addition, we can show contour lines, for example, which can aid with the assessment of the topography. Our teams are trained and capable of making observations and suggestions related to site placement based on the data set collected. In this case, a better location was available, allowing significantly less build cost and lead time. So far, we've learned about orthomosaics, digital surface models, contour lines, and more. As part of the candidate selection process, drones are also able to provide visualizations not previously available. For example, a 360-degree visual coverage assessment at the set of altitudes as required by the engineering team. An indication of microwave line of sight can also be noted in these assessments. As you can see, flight telemetry can be included in this assessment at predefined locations. In this case, as we reach north, south, east, and west at 180 feet. A note here, of course, is the lack of coverage opportunity towards the south. In this section of the delivery stage, we'll briefly focus on some of the unique features that we're able to offer clients to satisfy specific needs. In the previous sections, we saw the acquisition of data sets and the processing required to produce a point cloud. As in these examples, with enough resolution, a point cloud can be visualized as a three-dimensional model. As with the monopole, the same functionality can be applied to a compound view. We've provided animated fly-arounds for the monopole and compound to illustrate the usefulness of having three-dimensional data to analyze site builds and determine equipment installed counts. Once we have a working model, high accuracy measurements can be extracted from the data set. With an accuracy down to less than a 1/16 of an inch, aerial surveys of this kind provide an excellent method of acquiring accurate measurements for further structural analysis. As the intrinsic data is held in virtual form, there can be no interpretation or bad measurement performed by climbing teams. These are examples of actual deliverables showing equipment count, antenna layouts, and high-resolution pictures of placards. Of course, not forgetting, with aerial surveys performed in this way, a full data set is captured, rather than simply a climbing team with a specific objective. If those objectives change or are added to, no further site visits and climbs are required, as all data is immediately available from us as a desktop study. Effective use of drones can clearly reduce risks and save costs by utilizing these improvements in efficiency. By now, we've covered a lot of ground in this section. We've learned how drones can benefit both new site development as well as a little of what can be brought to the table for audit and analysis work on the existing site portfolio. It is also important to mention how all of this available data can integrate with other tools a client may already own. Interoperability is key when working with critical information, and we ensure our data seamlessly integrates with existing tools by being able to output in a variety of industry standard formats, of which some other key ones are listed here. For example, outputting in CAD would allow simple manipulation of drawings without the need to start CDs from scratch, or highly accurate map tiles for visualization on Google Maps. The options are limitless. Of course, none of this works if the client is unable to get to the data quickly, and so we have implemented online access, so data is available 24/7 on any smartphone, tablet, or laptop.